Um, my name is Nina, and my project is the Smart Vehicle Recognition and School Pickup Efficiency Enhancing System using Artificial Intelligence and IoT system. So, the problem I'm addressing is with my traditional school dismissal. Usually when the parent arrives, staff has to identify the vehicles manually and then yell out the student name. And this process is overall very confusing, has a lot of human error, and is just inefficient and time consuming. So the purpose of my project is to revolutionize the school pickup process by leveraging advanced technology to 1. Accurately identify vehicles using real-time license plate recognition. 2. Eliminate errors in matching parents. 3. Enhance efficiency by automating arrival notifications and streamlining operations for staff and parents. 4. Improve safety by securely managing and verifying parent-student connections through an integrated system. So my research question is that how can an automated system utilizing AI and IoT optimize school pickup processes? So my hypothesis is that an automated system using AI-powered license plate recognition, computer vision models, and IoT can streamline this process by accurately identifying vehicles, reducing errors in matching parent-students, reducing teachers and staff needed for dismissal, and enhancing both efficiency and safety. This is achieved through the combination of both a license plate recognition system and a mobile app, creating a reliable and user-friendly solution for schools. So, the overview of my solution has a plate detection system and a mobile app. So in the plate detection system, the vehicle arrives, a camera will capture the license plate, and YOLO will detect the license plate as an object. Then Paddle OCR will extract the license plate number and send this data through Firebase. And Firebase will match the plate number with the student information. Then this information, after matching, will be sent to the mobile app, where notifications will be sent to the Student Connect app. And the mobile app has two modes, the parent mode and teacher mode. So parents will receive notifications that their vehicle has been detected, while teachers can have a dashboard of all the students that have arrived, so they can manually call out the student name or have this be even more automated using a display and speaker system. In rare cases, maybe parent license plate may not be detected. So if there's no notifications, then parent can manually click an I'm here button and the notice back to Firebase through the system to notify parents and teachers that the student has arrived. So this button actually makes sure that the system will always work. This automated system is efficient, accurate, and safe. So now I will do a quick demonstration of the project. I have a short demo video that I would like to show.
Hello, I'm Nina, and this is the demo video for my project. This is a Raspberry Pi connected to a Pi camera. When a vehicle arrives, the Raspberry Pi and Pi camera system will detect the license plate and send a notification to the mobile app via Firebase. On each notice, it will display the student name, grade, and the time that the license plate was detected. In addition, you can also clear the notices, and in rare scenarios, if your license plate has not been detected, you can click the I'm here button to send a new notice to notify your student that you have arrived. There are many other functions of the mobile app. For example, you can edit your information, you can change the appearance to colors that you like, you can add all the license plates of your cars, you can link to your children, and last but not least, you can send a message to support and feedback if you have any questions. So that is the Student Connect system and mobile app.
Yeah, so that was the demonstration of the system and the app. So now I will move on to the material, software, and technology that I use to develop the system. So the Raspberry Pi and Pi Camera are the hardware that I used. YOLO, PaddleCR, Python, and Visual Studio Code are used to make the play detection system. Firebase is a cloud database used to connect the play detection system to the mobile app. And Android Studio, Flutter, Dart, and BlueStacks were used to develop the mobile app. Last but not least, Tinkercad is a tool that is used to modify the Pi camera case. So moving on, I will elaborate more on some of the tools that I used. So YOLO is an AI auto detection model, and it works by using the process frame function, which will take a frame from the camera feed and then pre-process the image. This will detect the license plate as an object and basically draw a green rectangle around the bounding box of the license plate. I did consider several alternatives to YOLO, but I concluded that YOLO is the fastest and most accurate. So that is why I use YOLO. And I also considered different versions of YOLO. I started with YOLO v5, then upgraded to YOLO v8 because YOLO v8 works better for my project. In addition, PaddleCR is the optical character recognition system that is used to extract the text from license plate. So it works by taking the cropped image from YOLO and previous code and running it through several filters, including grayscale filter, edge detector, noise enhancement filter, and then finally segmenting the characters and comparison to return the characters on the license plate. So I also considered several other alternatives to PaddleCR, but the main alternative that was considered is Tesseract, since this is most popular and has decent accuracy. So I compared PaddleCR and Tesseract for the text recognition accuracy and processing speed for the first experiment. Methodology, I basically used 10 different license plate images and ran it through the system. The results were that PaddleCR can successfully extract 75% of the plates accurately, while PyTesseract can only achieve 46% accuracy. I also ran through several other tests, such as inference speed, memory usage, variance for text length, and rotated text, and I found that PaddleCR is better than Tesseract for most of these tests. So, in conclusion, PaddleCR is overall better to use for this project. Next is Firebase. So Firebase is the cloud database that is used to store and connect the license plate information with the student data. So as you can see, here is a screenshot of the Firebase dashboard, and the data is organized into several layers. This makes it easier to connect to the mobile app. And this is another screenshot of like a code snippet from the mobile app. And as you can here, I use many instances of the data from Firebase to create the authentication. Next is how I made the mobile app notice. So each notice was made in a vertical list with these list box widgets. And when the parents or teachers receive notifications, the student name, time of arrival, and grade will be displayed in the list box. And however many notices that are received will display however many list boxes. If there are no notices, then the app will display the no notices screen. For the second experiment, I evaluated how environmental conditions affects license plate detection accuracy. So I conducted tests in 3 conditions: 1, bright daylight; 2, low light evening; and 3 is simulated rain, which I did using a plastic overlay on the camera lens. 20 vehicle images were tested for each condition, and the results were that for bright daylight, there was 95% accuracy, low light evening had 82% accuracy, and simulated rain had 65% accuracy. So to conclude, the weather and environmental conditions have a significant impact on recognition accuracy. So you may wonder how much time will be saved using this automated system. So based on the system's current processing speed, which is around 3 seconds per plate, it will handle around 10 vehicles in approximately 20 to 30 seconds. So it will save around 20 to 30% reduction in pickup time compared to the traditional pickup processes. Since the system's automated recognition and real-time notifications can reduce the time spent, this will help a lot for the dismissal process. In conclusion, this project can improve school dismissals. Using a license plate recognition system and the Student Connect mobile app, the system automates vehicle detection, reducing errors, and enhances safety and efficiency. Experiments have confirmed its accuracy and efficiency under various conditions. Some future improvements that I will consider include upgrading the hardware from a Raspberry Pi 4 to a Pi 5 to improve the computing power. I will also consider switching to a better camera and adding more features to the mobile app. So here are some citations and documentation. This project did not use anything that needs copyright permission, and references are listed below.